Okay. For example 2, we have a water tank drains at a constant rate. Again, when you see the word constant rate, you think linear function because the rate of change is constant. Okay, it contains 930 liters of water 3.5 minutes after it started to drain. So we have water leaving the tank. It takes 50 minutes for it to be empty. Let W be the amount of water in the tank. W is the amount of water in the tank, and T is the number of minutes after it starts to drain. So we want to find a model for the water in the tank in terms of the time, W of T. And so let's think to ourselves, what would the two variables be? Which one is dependent and which one is independent? Well, the amount of water in the tank depends on the time. So time is like your X, independent variable, and the water in the tank is like your Y. So if we want to write a model, we want to write the equation for that line. And again, I know it's a line because of that constant rate. So to write the equation of a line, I probably want to know what 2 points are. Well, I know 3.5 minutes. I have 930 liters. And after 50 minutes, it tells me this in the problem, after 50 minutes, it's empty. The tank is empty, so that means I have 0 liters. So I have 3.5, 930, and 50, 0. And so to write the equation of a line, the first thing I'm going to do is find the slope, which is y2 minus y1, 930 minus 0 over x2 minus x1. So 930 minus 0 over 3.5 minus 50. And if I type that in the calculator, I have 930 minus 0 divided by 3.5 minus 50. And I have negative 20. So the slope is negative 20. That makes sense because the tank is draining, and so that's a negative slope. And then I'm going to use the formula y minus y1, and I'm going to choose this point. Y minus y1 equals m times x minus x1, and the slope is negative 20 times x minus x1, so x minus 50. And if I isolate for y, I get y equals negative 20x plus 1,000. But remember, if I want to go back to the variables I'm supposed to be using, I should have the water in terms of time is equal to negative 20t plus 1,000. So I went back to the variables that I've been asked to use in this problem. And it also helps us remember what we're doing in context when we use variables like w and t. So I have w of t equals negative 20t plus 1,000. That's the answer to the first question. And then the rest should be pretty easy to follow through from here. Interpret the slope of your model in context. The slope is negative 20. Let's think what that means. That means I'm losing water. How much water? I'm losing 20 liters per minute. Remember, it's always like the slope is for every 1 unit of x. And so the tank is losing and remember, in context is supposed to be about the problem, is losing 20 liters of water each minute or per minute. And I do need to say each minute or per minute. That's saying for every 1 unit of x or t here. Interpret the w-intercept. Think of w as like the y-intercept because w was like our y here. And the w-intercept was 1,000. What does that mean? Well, we wrote on the previous page that the y-intercept is when x, or when t, is equal to 0. So let's think about that. When the time is 0, w is 1,000. So that's the initial amount of water in the tank. So the tank starts initially with 1,000. That should be 1,000 liters of water. Okay. Use your model to find the amount of water in the tank after 30 minutes. So the model above is in yellow, and I'll put 30 in for T. So that's negative 20 times 30 plus 1,000, and I can put that into the calculator, or I can do it in my head, and it should be 400. So 400 liters remains after 30 minutes. Give a reasonable domain and range for your model. Well, if we think about what's happening with this model, I have the water and the time. At time 0, I have 1,000 liters of water. That's at time 0. And remember, it took 50 minutes for it to drain completely at a constant rate. Was that right? 50 minutes for it to drain completely? Let's see, 50 minutes for the tank to empty, yeah. So what is a reasonable domain and range in context? Well, the domain would be time, and a reasonable time would be from 0 minutes up to 50 minutes. We wouldn't want to go past 50 minutes because after 50 minutes, we would have negative water, which doesn't make sense. So at 50 minutes, the tank is drained and we're finished. The range is like our Y values or our W, the amount of water in the tank. And the water in the tank could be as low as 0, right? It goes as low as 0 and it gets as high as 1,000. Remember, we want to go range goes from bottom to top. Domain goes from left to right. And so range, if you look from bottom to top, it goes from 0 to 100. Domain from left to right, 0 to 50. All right, that's it.